Hello and welcome back. So, recently I started investigating where the Bitcoin conversations are happening, and I've seen a bunch of websites like bitcointalk.org, which in the past was really important. Nowadays looks like it's not as popular as before. Now it's just full of people talking about, I don't know, strange services like copywriting in the same forum, creating this void content. I didn't see really great conversations there. I've seen some good quality conversations in the Bitcoin Stack Exchange, in the mailing list, and of course, as I discovered chain code in a parallel series of video, um, I started their onboarding tutorial, which is properly technical, and there I discovered also about the IRC chat on Libera, where there are some of the contributors of the Bitcoin core repository. They are having different conversations. There are several conversations, and one of these is the conversation where twice a month they discuss a PR all together for they discuss it so beginners like me can watch the conversation, read it, understand how to do the exercise of reviewing PR. So I've discovered all these places where there are some really good conversations ongoing. Now, I collected some topics which to me look interesting. These topics are technical. I'm looking for technical topics. First of all, then maybe I will expand my activities and my studying activity to topics which are less technical, less development centered. However, to start, there's first of all ARC protocol. So they're all current issues being discussed. So there's this ARC protocol. Then we have the covenants proposals. There are I have been through these topics superficially, and I've seen there are three main proposals on how to implement covenants in Bitcoin transactions. Then we have UTR-XO and SPV clients, which are also something really interesting being discussed. Then we have BitVM and BitVMX, and finally silent payments vs paynims. Therefore, my goal today is to understand something more about these topics. First of all, where are they being discussed? If only, for example, normally a topic is being proposed by someone in informal discussions, like in the IRC chat, or maybe in the Bitcoin Dev mailing list, or they can be proposed in these places, and then they are being distributed. These proposals are being distributed not only through these channels, but also through channels like Bitcoin Stack Exchange or Bitcoin Optech, which is a really cool digest of what's happening in the space. And when someone finally agrees that this is interesting and has to be explored, normally the proposals are being published as BIPs, BIPs, and these BIPs normally are published in the GitHub, where we have this agreement to store more formal conversations. So first of all, in GitHub, an issue is being opened normally. In the issue, we can observe formal discussions where there's already some code. The code can be reviewed, but it's not already a solution, because the solution, the proper code solution, then is a PR which is linked to the issue, and in the PR review process there's the code discussion. So first of all, in the issue there's a formal discussion about the architecture, the necessity, how this proposal is interesting for the common interest. Therefore, when it arrives already to the PR review, it's something really solid, which already has a shape, which can be discussed, can be modified, can be adapted. It can even be cancelled. Arriving to the PR stage doesn't mean that this will already be realized. Therefore, let's see these topics at which points they arrived and where are they being discussed. So in which of these places I named are being discussed, and who is participating to the discussion, and how popular are these topics and proposals among the community. Do they create any divergence? Of course, I will not be able to discuss all of this today. I will just try to go through the 5 topics I mentioned. So the ARC protocol, the covenants, UTR, XO, and SPV clients. And the 4th is BitVM and BitVMX, and the 5th is silent payments vs pay names. Okay, so let's start with the ARC protocol. So let me check. Okay, I can share my screen with you. Sorry. This is the one. Come on, man. Okay. Okay, in the new tab, and why it's not showing it? What the fuck? Sorry, having some issues with my tabs. Yeah, please show this. Okay. Not now. Okay, so finally I can do it. ARC protocol. Okay, so here in this case we have a website, and it's already introducing it superficially, and the ARC. Okay, so you can read everything like me. Yeah. ARC is a layer 2 protocol for making off-chain Bitcoin transactions. initially published on the Bitcoin Dev mailing list as TBD XXX by Burak, has since been named ARC, and the protocol design has advanced significantly. So Burak is the guy who proposed this. Okay. Let's see if we are really on the right track. Burak. Okay, so this guy here, which is a really young person, is the author of this proposal. The initial author, of course. Then other people joined the conversation, and as they recognized that this may be useful or something that maybe they were thinking in a similar form, so they merged the discussions, and he's recognized as the guy which started the conversation for this instance of the conversation. So solving Lightning's inbound liquidity is a problem. Problem is focus of new layer 2 Bitcoin protocol. Okay. The new protocol's 24 yield creator says Lightning inbound liquidity requirement requiring users to commit funds to the protocol even when they're just receiving payments doesn't make any sense. Okay, so the issue on which this solution is focusing is the requirement of liquidity even when it doesn't make any sense. So this guy, self-taught Bitcoin developer and research who disrupted a large chunk of Bitcoin Lightning Network last year, is now proposing a new layer 2 protocol dubbed ARC that he says will solve Lightning inbound liquidity problem. So this information is just some superficial information provided by CoinDesk. Inbound liquidity is the ability to receive funds on Lightning, a layer 2 payment network introduced in 2016 that enables cheaper and faster Bitcoin transaction. Oh, Jesus. But that receiving capacity must first be established by committing funds and making outbound payments. Keseli, I'm not sure how to read it, says that much like the Lightning Network, ARC will make the dominant cryptocurrencies transaction cheaper and faster, but the new protocol will eliminate the need for a recipient to commit funds. Lightning has many problems, but number one to me is the inbound liquidity problem. Imagine a payment system where you need money to receive money. This doesn't make any sense. Novice of Lightning Network running non-custodial setups quickly realize one thing: the system works more like an abacus than a bank account. Users must commit Bitcoin to a channel to create liquidity. Sending Bitcoin reduces your funds as expected, but receiving Bitcoins also reduces your capacity to receive additional funds, much like the limited space on an abacus. The model makes sense for users who want to send Lightning payments, but not for users who simply want to receive them. They too must pony up funds and either send payments to generate that inbound liquidity or acquire it through other means like liquidity marketplace. That burdensome requirement for all Lightning users to acquire liquidity before using the system simply should not exist. The objection, he explains, is what inspired him to create ARC. So this guy says he has been working on ARC mostly solo and hasn't incorporated on raised capital. choosing to keep the project open source and donation funded, but Arc is already receiving significant attention from prominent Bitcoiners. Excited to see new ideas like Borax come to Bitcoin, tweeted longtime Bitcoiner and Human Rights Foundation Chief Strategy Officer Alex Gladstein. Wrong side of the block size war. This guy says he went down the Bitcoin rabbit hole in 2017 after watching a YouTube video about the mining process. He was fascinated by how a network could generate value from electricity and decided to dive in head first. I dug deeper into the details of how Bitcoin works under the hood. I built a Bitcoin wallet based on what I had learned, and then over time I realized Bitcoin doesn't scale. This happened during Bitcoin's contentious block size war, when part of the community known as big blockers called for an increase to the standard 1 megabyte size of Bitcoin blocks in order to scale network capacity. Another faction, the small blockers, who eventually prevailed, argued that blocks should be kept small to maintain decentralization. The big blockers eventually created Bitcoin Cash, a version of Bitcoin with enormous 32 megabyte transaction blocks and additional functionality that Caselli thought would be useful in creating a Uniswap-like automated market maker. I thought it could scale on the base layer, so I joined the big blocker camp. So he was in the big blocker camp, the Bitcoin Cash camp, and I hung out there for a few years. I wanted to build the AMM on Bitcoin Cash first, but in turn, it turns out Bitcoin Cash is not expressive enough to build an AMM, he said. So he turned to Liquid, a federated sidechain on secondary blockchain that interacts with a primary blockchain created by small blocker Bitcoin infrastructure company Blockstream. So it's a fork of Bitcoin, but with additional features like Caselli and friend used to finally build the long-envisioned automated market maker, which they eventually branded BitMatrix. So BitMatrix didn't garner the success Caselli had hoped for, so the young developer took his talents to the Lightning Network. Wow, what a journey. I shifted my focus on Lightning to improve Lightning, and that's how Arc got started. Arc in a nutshell. So after Caselli turned his attention on Lightning, he confronted the myriad of problems currently besetting the network. As he describes them: poor user experience, suboptimal privacy, payment routing challenges, and then the onerous liquidity requirements. He began working on a Lightning wallet about 6 months ago to address these issues, he says, and what began as an attempt to create a best-in-class Lightning wallet morphed into a standalone protocol now known as Arc. So the time of when this article was published was in June 2023. So this guy started in January 2023 to work on this protocol. He started working on this wallet, but ended up creating a new protocol. At some point, I realized this doesn't look like Lightning at all. He explained, you can pay invoices, you can get paid from invoices. It's a Lightning wallet, yes, but internally at its core, it's a different kind of design. Caselli says Arc is much like Lightning in that it scales Bitcoin by transacting off-chain. However, instead of requiring users to commit funds at the outset as a way of establishing liquidity, the new protocol uses Arc service providers, ASPs, who are always on and provide 24-hour liquidity services for a fee. Okay. Lightning off-chain channels payments are like a game of ping pong. Coins change hand within a 2 of 2 multisig indefinitely until the channel is closed. A 2 of 2 multi-signature or multi-sig transaction requires two parties to sign for the transaction to be valid. Arcs of chain payments replace traditional channels with a shard unspent transaction output model that uses virtual unspent transaction outputs, which facilitate unidirectional, one-time only payments. It's like an atomic single hub payment. So it's me, I'm the sender, my partner is in the middle, my ASP, and the recipient is on the other end. We collaboratively signed the 2 of 2 to push my money to the service provider. The service provider pushes the funds minus the liquidity fee to the recipient. That final push by the ASP is actually an on-chain coin join. A way of combining several Bitcoin payments from multiple spenders to produce a single transaction whose history and ownership are obfuscated. Okay. Caselli says CoinJoin gives ARC a privacy edge over Lightning, and if ARC succeeds, will that spell doom for Lightning? Not really. According to the developer, the two systems will complement each other. An ARC service provider is also a Lightning service provider, said Caselli. To be an ARC service provider, you run a Bitcoin node, you run the ARC service provider node, and also you run a Lightning node. What's next? ARC's development is still in the early stage. Caselli is currently focused on answering questions from the Bitcoin community and finalizing technical specifications. After that, he plans to put on his entrepreneurial hat and shift to the prototyping and raising capital. The mid or long-term vision for me is to build a company like Lightning Labs or like Blockstream, said Caselli. So I'll be building ARC Labs to build the key ARC infrastructure, build the client, the daemon, the CLI, the SDK, the tooling around it. So I'll be building an infrastructure company for profit, and I'll be raising for that. So this article is by Frederick Munawa. Okay. Interesting article, really good one to start understanding this topic. It's a really good way to start, yeah. So we have an idea about what is the ARC protocol now. Is a complement to the Lightning network, and yeah, it creates basically it defines the need of a service, the ASP, ARC service provider, which basically is providing liquidity for the transactions. So this allows people to not maintain a channel in order to receive money. Nice. This is really cool. Exploit a Bitcoin block parsing bug that had downstream on certain Lightning nodes. interesting. So he first played around with lightning and finally broke it one day. Okay, so introducing Lightning Pool, a marketplace for Lightning channels. Okay, so this type of service is what comes from the same type of observations that Burak made, and this is something he was building before working on the ARC protocol, which doesn't look really active now. So is this for no? Well, okay, we made yeah, so we discovered a base for this. Okay, so this is the GitHub for the ARC protocol. And he's already connecting to the next topic, which is governance. Okay, so this is a website which I imagine has been made by Burak or someone which works with him, and for now it's explaining how the first solution will work. Oh, so this is just okay. This is just the website GitHub. Let's see if there's something. I mean, if they have only this repository, it means that there isn't anything else really. For verifying Bitcoin proof of work using BTC block headers and ARC works. What? This is something which looks like not really relevant. Let's have a look. If they, I'm not sure if I can access this. No, not now. Okay, so this is just for the website. I will just leave it like this. Is there any other place where this protocol is being discussed? ArcDev info. Okay, so the idea here is I see this interesting way of phrasing it, virtual channels. Nice. they have, oh look here, it looks we have more. Repositories. Covenant-less Arc implementation written in Rust. Bitcoin script contract definition for the Arc protocol using introspection opcodes. So this looks like the repository where the actual protocol is being written. Well, at this point I will just close the first research here. Oh, look here, Bitcoin Optech has also reference. So Arc is trustless joint pool style protocol where a large number of users share a UTXO by accepting a counterparty as a cosigner and all transactions within a certain time period. This spreads the cost of on-chain fees from using that UTXO across many users, minimizing their individual costs. The users can either unilaterally withdraw their bitcoins on-chain after the expire of the time period or instantly and trustlessly transfer them off-chain to the counterparty before the end of the time period. Normally, a user will simply roll their bitcoins into another contract with the counterparty, which can be highly fee efficient when done with many other users at the same time. Alternatively, the counterparty may help the user make a payment on chain through LN, Lightning, or through any other protocol supported by the counterparty. So Arc can be implemented on Bitcoin with no consensus changes required, but it will support a larger number of users, making it much more fee efficient if a covenant feature like is added to Bitcoin. Okay, so this protocol has a synergy with the next topic, which is the topic of covenants, which have various forms. In this case, they cite the check template verify form. So I will go to the covenants, and then maybe we will have the possibility to understand this synergy and why they're saying that with no consensus change. So this will be a deployment of the Arc protocol, which does not require anybody to it will not imply any type of fork, maybe just a soft fork. So who wants to use it? However, the covenants, from what I understand, imply greater impact on the consensus, in the sense that the covenants, even if they just need an opt-in, so if you want, you use them. However, the type of transactions that will result from the covenants future may imply that those who do not use covenants may be in position to refuse a transaction because they may create an incongruency with nodes which are not opting in for covenants. So considering that Arc has some synergies with covenants like check template verify, and considering that in case you combine it with a covenant, you basically, as they're saying here, you are giving users much more possibility to optimize, to model their transaction as they want. Well, yeah, there's this type of vision where which is these implications are kind of supporting the idea of covenant future being added to the Bitcoin network. Okay, so let's go and explore the covenants, which is the next topic. Okay, so covenants are a category of proposed changes to Bitcoin's consensus rules that will allow a script to prevent an authorized spender from spending to certain other scripts. So this phrase here is saying that covenants allow you to pay somebody, so to authorize them to use a certain UTXO with conditions. So you can decide by giving to someone, by paying someone, you can decide how they will be able to spend that UTXO, of course, with limits. So the first thing is that the conditions that you can express with covenants restrict only the next spending action that regards that UTXO. So it's not a perpetual condition. It's just one hop condition. So in the context of Bitcoin, the most useful definition of covenant is that it's when the script pub key of a UTXO restricts the script pub key in the outputs of a transaction spending that UTXO. Okay, therefore you are giving money to someone and at the same time you're telling them the conditions at which they can spend it. For example, a covenant may normally only allow spending to a whitelisted set of scripts. So this is a warning. This implies that someone may control and censor, or let's say decide to whom you can pay, such as returning bitcoins to the user's own balance or spending to a staging address that only allows spending to an arbitrary address after a period of time. Okay, so you can basically create loops where money can only get back to you, or you can create a time restriction. For example, you give your son a UTXO and you say you can spend this UTXO only when you're 18, only after that. So these are type of restrictions, but also you can put something like you can spend this UTXO only on this whitelist of addresses, and that's bad in some cases, or it's good, depends on the context. Whatever this context may be, it's a warning. We need to pay attention to not break the fungibility property of the coins. So this allows for contracts basically, but yeah, we need to pay attention that this does not imply that someone can exclude someone else from the entire economy. Primary code and documentation, enhancing Bitcoin transactions with covenants. So, okay, Russell O'Connor and Marta Piekarska from Blockstream, they published this white paper. And here there are some articles. An early description of covenants in Bitcoin. Okay. I think that these two are a type of covenant. I'm not sure. Any prove-out, yes, also. Okay. This is interesting also. So there's also the discourse of how to deploy this again, which is really important in the sense that, for example, I'm not sure if it's cited here, for sure it is. I've seen somewhere that some security measures changed the covenant initial design, implementing a way which does not allow for accidental opt-in for covenants. Therefore, you need to intentionally declare that you want to use covenants. So there are some nuances in when you build the transaction, which will indicate that you are sure, you are consciously selecting to use it. However, it's still, there are still all of those issues which I cited about the consensus modification and the implication on the transaction verification process. Okay, poll of opinions about covenant proposals. So a dev posted on the Bitcoin dev mailing list a link to a public poll of developer opinions about selected covenant proposals. Yuval Kogman noted that developers were asked to evaluate both the technical merit of each proposal and their vibes-based opinion about its community support. Without developers being able to express all possible combination was one of, so it wasn't possible for developers to express all possible combinations of the two through the poll's limited options. So he was noting this incoherence or limitation of this poll, let's say. Therefore, Jonas Nick requested separating technical evaluations from community support, and Anthony Toms suggested simply asking developers whether they had any outstanding concerns about each proposal. Nick and Toms separately recommended developers link to evidence and arguments supporting their opinions. All the discussion highlighted faults in the poll. A showing of more support for some proposal over others may help covenant researchers converge on a short list of ideas for the broader community to review. Okay. Let's see if here is just a link to what we already have seen. Okay, so here is just a meta note about how the conversation is going. Okay, so here I want to see if in this paper we have like different types of covenant or just one type, the check sig, sig hash, check sig from stack verify, check sig from stack. Okay, this is one of the covenants techniques. Check output verify, check sequence verify. Check put verify. Okay. Well, we have a first interesting document. However, here I see that these are exactly what I wanted. So checksig from stack is the one discussed in this paper, if I'm not wrong. A paper dedicated only to this. So here we already have a BIP, if I'm not wrong. Yeah. Okay. Then we have check template, verify, CTV, criticism, composition, history. Okay, so in this case we also have a BIP already. And also for sig hash any preview out. For the proposed L2 layer for, okay, so this is also relevant. It's a proposed enforcement mechanism for LN that allows any later challenge state to replace any earlier challenge state. Although L2 can be used with a penalty mechanism similar to the one used with the existing LN channels, L2 doesn't need the penalty mechanism in order to be secure. So currently, when you open a Lightning channel, you have this obligation to basically back up continuously the status of the channel. If for some reasons you lose the files or corrupt your files, and you when you're required, you publish an obsolete version of these backups. So when you make a reference to obsolete status of the channel, you will be penalized. And if I'm not wrong, the penalization equals to all your funds in that channel being sequestrated. I'm not documented about all the procedure in this case, but it looks like that L2 is a work to relax this without losing security. And for L2, it looks like this covenant is necessary. So L2, from what I understand, is a proposed enforcement. It's not something that is already working. So as we can see, it's everything connected. It's everything really intricate. Therefore, all these three forms of covenant, which are the principal forms from what I've seen in my previous research, they're the principal, let's say, most popular. I'm not sure how they relate to each other if we want to classify them by popularity. And each of them has a different mechanism which allows users to put conditions on their transactions, on the next transactions in which a UTXO will be used. Okay. So let's see this sig hash and out. This is an updated version of the sig hash no input. This is a proposal for a signature hash, sig hash, where the identifier for the UTXO being spent is not signed, allowing the signature to be used with any UTXO that's protected by a similar script. For example, that uses the same public keys. And no input style sig hash is necessary for the proposed L2, as we already said. There's a lot of conversation going on it. We can see it started. This website, Bitcoin Ops, started recollecting information about this conversation since 2018. And if we go to the BIP, we have this information. Let's see. So consensus, it will imply a soft fork, as we mentioned before. Who wants to use it, who doesn't want. In theory, will be free to not use it, and a deployment has to be designed in a way that will not compromise, will not imply a hard fork in the moment in which a node which is not using this type of consensus can't accept a transaction because it's not respecting the parameters it expects. So the authors for these BIP are these two guys here, Christian Decker and Anthony Towns. Anthony Towns looks like the one supporting it more than others. I'm not sure if Christian Decker maybe is as important, is pushing it as the same intensity as Anthony Towns, but I've seen Anthony Towns named a bunch of times, so I'm like more familiar with his name. And he's not an American basketball player, if I'm not wrong. We couldn't find the page. Okay, my team. I don't want to open this website here. So he's an Australian Bitcoin developer. Well, however, let's not lose time in these things. I've seen Christian Decker in other contexts, so now I know that he's also supporting this BIP. So the BIP is in draft. Standard track, I'm not sure what's this. And this was created in 2017. Wow. This is impressive. So yeah, in this website they have traces since 2018. However, this was published nearly a year before, at the beginning of 2017. and it requires 340, 341, and 342. Which are short signatures. So, okay, I think this is a BIP which is necessary for a lot of BIPs in reality. It's not strictly connected to their arguments. And this is Taproot, on which also a lot of BIP are based. A new SegWit version. And then we have validation of Taproot scripts. Okay, this is a initial scripting system under BIP 341. So they are all connected, and this is basically the infrastructure that comes on cascade logic as necessary for realizing these sig hash. Let me see one thing. So status final. So this is in its final status, which I'm not sure if it has been already created and implemented in the main network. I need to check what these statuses mean. And it was created after, so it was identified as a necessity and it has been discussed. This is also in its final status. And this is another place where things have been discussed, but now they're not discussed anymore. Here in the Linux Foundation website, and also this one has been promoted to final status. Okay, so introduction. The BIP describes a new type of public key for TypeScript transactions. It allows signatures for these public keys to not commit to the exact UTXO being spanned. This enables dynamic binding of transactions to different UTXO, provided they have compatible scripts. So you create basically transactions in which different UTXO can fit. Off-chain protocols make use of transactions that are not yet broadcast to Bitcoin network in order to renegotiate the final state that should be settled on chain. Okay. In a number of cases, it's desirable to respond to a given transaction being seen on chain with a predetermined reaction in the form of another transaction. Often, the same reaction is desired for a variety of different transactions that may be seen on chain, but because the input signatures in the response transaction commit to the exact transaction that is being reacted to, this means a new signature must be created for every possible transaction one wishes to be able to react. Okay. So here we have already some description. So by design, sig hash any prevout and sig hash any prevout script introduce additional potential for signature replay. That is, they allow the same signature to be reused on a different transaction. when compared to sig hash all and sig hash anyone can pay signature. Both sig hash all and sig hash anyone can pay signatures prevent signature replay by committing to one or more inputs. So replay of the signature is only possible if the same input can be spent multiple times. So as a consequence, implementers must ensure that BIP 118 public keys are not only reused when signature replay cannot cause loss of funds. So these are the security concerns, signature replay, malleability, privacy considerations. Why a new public key type? So the new public key type is the mechanism I was mentioning before, which will allow to be sure that nobody's using this for by error, if I'm not wrong. Yeah, I'm not sure if it's the same thing they're mentioning here. Now I'm getting a bit tired, so I will just continue with a good pace. So older software will continue to operate without modification. Nodes that have not upgraded to support 341, which is sure. No, Taproot. Okay. We'll see all Taproot witness programs as anyone can span scripts, and nodes that have upgraded to support this, but not 180, will simply treat any non-empty signature against the BIP public key as valid. As such, nodes are strongly encouraged to upgrade in order to fully validate signatures for the new public key type. Not upgraded wallets can receive and send bitcoins from non-upgraded and upgraded wallets using SegWit, traditional pay to public. Depending on the implementation, upgraded wallets may be able to send to SegWit, blah blah blah. And do not prevent the transaction from being broadcast due to consider outputs non-standard. So okay, this is something I was mentioning before, that it's necessary to design things in a way that all nodes not implementing this BIP, so those who are not implementing it, we want to avoid that they do not that they prevent transactions from being broadcast. So when you create a transaction, you send it to your list of nodes, and they check it if it's correct before sending it, broadcasting it again. And if they are not implementing the BIP, we want to be sure that in any case they broadcast the transaction without thinking that it's not a good transaction, as the outputs are non-standard. The SIG hash non-input flag was first proposed by Joseph Poon in 2016. Okay, so it has its roots in a really far time. It's already 10 years. Let's see, who's this guy? Okay. Okay, so this was the first type of covenant. We have the check template verify. So this one, let's see if they have a time for this other proposal. So I see 2019 in Bitcoin Ops as the oldest moment. This BIP has been created in 2020, and this one, which we finished to discuss, has been created. This BIP has been created in 2017. This in 2020. Wow. Okay, so the author is this guy, Jeremy Rubin. Let's see who's this guy, his face. Maybe I've seen him somewhere. Sincerely, I do not remember his face. I'm still new, I don't know faces here. So this BIP proposes a new opcode check template verify to be activated as a change to the semantics of Opino. So a change to the semantics of this reserved operational code. Check one thing, like I want to see if, so he's mentioning the fact that this is a new opcode. In this instead is a change in the way the transaction is built. Probably for transcript transactions, all signatures for the public keys to not go into the. So this is not an operational code. This is so this is kind of more complex. I'm not able to summarize it at best. But it's a change in the hashing mechanism when you create the transaction, so you do not bind the previous output. So basically in this transaction, you later, after the creation and publication of the transaction, you will be able to assign dynamically a UTXO. Instead, this is new operational code. So using one of the reserved operational codes, this one will be created, activated, implementing some new semantics. So this operational code will use the non-operational code 4 as a soft fork for upgrade. And this operational code will do the following. There is at least one element on the stack fail, otherwise the element on the stack is 32 bytes long. The default check template verify hash of the transaction and the current input index is equal to the element on the stack. Okay, so I'm not understanding it. I understand that this will implement a stack. Okay, the BIP introduces a transaction template, a simple spanning illustration that pattern matches a transaction against a hash transaction specification. OP check template verify reduces many of the trust, interactivity, and storage requirements inherent with the use of pre-signing application. For more details on applications, please see the references. The below code is the main logic of verifying check template verify, described in Pythonic pseudocode. The canonical specification for the semantics of OP check template verify is implemented in C++ in the context of Bitcoin Core, can be seen in reference implementation. Okay, so I'm not going through the code immediately. So, okay, the activation logic is deleted from the BIP and is more appropriately discussed elsewhere. Okay, interesting. Reference implementation, the rationale. Okay, one interesting thing will be to understand, to compare these governance techniques and to understand like the different impacts and also the set of new possibilities and new risks that are being introduced with each one. And will be also nice to understand if these covenants do not overlap in some way. So studying all this stuff, we can classify them respective to each other. And yeah, let's see, not too similar alternatives. Yeah, whatever. Okay, so this is I will say a younger covenant technique. Check template verify. And the other. And now we have the last one. So we have seen the SIG hash and ePrevout, which allows you to put in the transaction, to write in transaction UTXO, which is decided after a transaction has been published, if I'm not wrong. So you are not forced to use a specific UTXO pre-declared in the transaction construction. Check template verify is an opcode that allows you to define a template for the transaction in which the UTXO will be used. And then we have check signature from stack. Signature from stack, right? Yeah. This BIP describes a new opcode for the purpose of checking cryptographic signature in Bitcoin scripts against data from the stack. So this BIP has been created recently by Jeremy Rubin, which is the same guy which created BIP for check template verify, and Brandon Black. Let's see, Brandon Black. Oh Jesus, all the people's names. They have all the same names in the United States. Swan Bitcoin, okay. Covenants make script great again. Fuck. When verifying Taproot scripts, spends having leaf version, blah blah blah. We propose check sig from stack to replace op success. Okay, so in this case, they want to conditionally replace or definitely replace this op success with op check sig from stack. Okay, so it's another stack script. If fewer than 3 elements are on the stack, the script must fail and terminate immediately. The public key, message, and signature are read from the stack. The top 3 elements are popped from the stack. If the public key size is 0, blah blah blah. Okay, so this is another proposal which this also can be, they think it can be deployed as a soft fork. And well, it looks like it gives you some flexibility on who can spend, right? Check signature from stack. A public key, a message, and a signature. Let's see if here they have some good description. Side chains that sometimes proposed for implementation of Bitcoin. The opcode allows checking whether a signature signs an arbitrary message. The opcode takes 3 parameters. Okay, paying for signature. If Alice controls a private key that can sign a transaction, ping Bob. Bob can use OP to trustly offer to pay Alice for the signature he needs. More recently, protocol involving paying for signatures typically assume the use of adapter signatures that are more private. Alice might want to delegate the authority to spend her coins to Bob without explicitly creating an on-chain transaction. If Alice designs her script with this sort of delegation in mind, she can put Bob's pub key and message and use OPSI to prove that she's delegated spending authority to that key. Okay, so it's delegation of a signature. This looks kind of less simple to me at the moment. But yeah, it's a huge topic. So now how this can be implemented with ARC protocol, I'm not sure. Let's see here how they put it again. ARC can be implemented on Bitcoin with no consensus change required, but it will support a larger number of users, making it much more efficient if a covenant feature like check template verified is added to Bitcoin. Okay, because here we have to delegate in some way to that ASP. So you say the ASP, okay, take this money and create some transactions with this template. This makes everything easier to not need to trust anybody, so it will be easier to realize an architecture where the ASP needs to take a fee and then send the money to the other guy. Okay, so I will also study a bit deeper how ARC is combining with covenants. Now, to finish the review of topics, we have UTREXO and SPV clients. Let's see, this is, well, of course it's related. UTREXO. Okay. UTXO is a proposed alternative to UTXO set for allowing full nodes to obtain and verify information about the UTXOs being spent in a transactions. A Merkle tree updated after every block accumulates references to every unspent transaction output, allowing nodes to skip storing the outputs themselves. New transactions can be distributed with the UTXO, they span the Merkle branch, proving they're part of the UTXO Merkle tree. Overall, this can decrease the amount of storage full nodes need to a minimum amount at the cost of modest increases in bandwidth. UTXO will not change Bitcoin security model. Okay. So there's a paper for this. Decoupling network state size from the storage requirements of individual machines will reduce hardware requirements of validating nodes. We introduce hash-based accumulator to locally represent the UTXO set, which is logarithmic in the size of the full set. Nodes that attach and propagate inclusions proof to the inputs of transaction, which along with the accumulated states give the information needed to validate the transaction. Okay, so this, I would say, it's easy to understand. So instead of memorizing the whole database of UTXO, the UTXO set, which grows continuously, well, we have basically this idea of representing this set in a Merkle tree, therefore reducing dramatically the memory, the storage which this set is occupying in the node's memory. Light clients, nodes that do not store the system state and do not validate transaction, can still obtain some assurance about transactions through simplified payment verification, which leverages Bitcoin proof of work and block commitment scheme to give compact proofs of transaction inclusions into a not necessarily valid blockchain. SPV, while reducing the resource cost of operating a network node, comes with a number of security and privacy weaknesses not present in full nodes. SPV nodes rely on fully validating nodes to enforce the rules of the system, and they cannot do themselves. An adversary with sufficient hashing power can present transactions which SPV nodes will accept as confirmed, but which will be rejected by fully validating nodes. While improving the security and privacy of SPV is a promising area of research, this work focuses only on fully validating nodes and on reducing the resources requirements to run one. In this paper, we present UTXO, a method for greatly reducing the storage needed to run a fully validating node in hardware setups where disk I/O speeds and storage requirements are the bottleneck. This can significantly accelerate the validation process or make validation possible on hardware where it previously has not been. UTXO has a hash-based cryptographic accumulator and introduces a new type of node, the compact state node, which stores only an accumulator representation of the state. These nodes require additional inclusion proofs before they are able to verify transactions. And while the CPU time cost of this verification is small, the network bandwidth of this proof is a trade-off made to achieve the lower state size. We explore several techniques to limit the size of these proofs. We observe that the spending patterns of outputs in Bitcoin follow a Pareto distribution where many outputs are short-lived. We can exploit this locality to keep outputs that are likely to be removed clustered together and use shorter overlapping proofs when proving their inclusion. Okay. Therefore, it's a way to reduce the storage necessity. So basically these will also allow to, it's an incentive to run a full node, basically, a compact state node, instead of an SPV, which will still be interesting in many cases, but there's a portion of people running SPVs which maybe now will have the incentive to upgrade to a compact state node. So this is interesting. Libro Foresta. Okay. And economical outputs, okay. Well, this was kind of simple. So BitVM and BitVMX. Let's see. BitVM and BitVMX. What is coming? Isn't there any optech? Okay, accountable computing contracts. These are payments that the receiving party can spend if they verifiably run a specified function on a specified set of inputs. Okay, if the receiving party doesn't run the function or doesn't run it correctly, the paying party can reclaim the payment after a period of time. Wow, so it's distributed computing network using bitcoins. Nice. Merkelize all things. Okay, so okay, so also this topic is also connecting to the covenants. For example, check template, verify, developer moons, settler posted to these places, Bitcoin Dev and Delving Bitcoin, which is another great place to follow the conversation, the propose. So this guy posted the propose to posted to propose two additional opcodes to be used in conjunction with the already proposed check template verify. OP template hash, which takes a list of transaction elements and converts it into a CTV compatible hash, and input amounts puts the Satoshi value of some or all of the inputs on the stack, which can be used as a parameter, blah blah blah. Together, these opcodes can create vaults with similar properties to those possible in 345 opvault. The opcodes may also be convenient for implementing more on-chain efficient types of accountable computing. Okay, and when is this newsletter from? So this is from this year, 4 months ago. Let's see the original post of this guy. So in Delving Bitcoin, he posted in December 2024. Okay. And then also in the Bitcoin Dev. Nice. This is really interesting. So BitVM is a technique to implement accountable computing contracts. And then we have also BitVM X. Which looks like not being in this index. So let's see if we can look for it, specifying the Bitcoin Optech domain. Okay, so BitVMX. Alternative to BitVM, Sergio Damian Lerner and several co-authors posted to the Bitcoin Dev mailing list about a new virtual CPU architecture based in part on the ideas behind BitVM. The goal of their project, BitVMX, is to be able to efficiently prove the proper execution of any program that can be compiled to run on an established CPU architecture such as RISC-V. What the fuck is this? It's a standard instruction set architecture. Okay, so it's a way to classify CPU architectures. Like BitVM, BitVMX does not require any consensus changes, but it does require one or more designated parties to act as a trusted verifier. That means multiple users interactively participating in a contract protocol can prevent any one or more of the parties from withdrawing money from the contract unless that part successfully executes an arbitrary program specified by the contract. Lerner links to a paper about BitVMX which compares it to the original BitVM and to the limited details available about follow-up projects from the original BitVM developers. An accompanying website provides additional information in a slightly less technical form. Okay, so when is this from? Oh, this is from 1 year ago. So, okay. BitVMX. Just interesting stuff. So Das Junior created this BIP. Yes, like the process of how to create BIPs. Oh, maybe here I can see the states. Status: draft, active, proposed, deferred, rejected, withdrawn, final, replace, obsolete. So final looks the one where things are deployed. Draft is the very first one, first state. Okay. So I have an idea about BitVM, BitVMX now, and how they also are kind of related to the covenant. And silent payments vs pay names. So silent payments. So this set of interesting topics have been suggested to me by this developer, which I'm not sure who wants to a disclosure on our conversation, but he's kind of mentoring me since I started this this learning path. I had the necessity to have a conversation with someone, so I reached out to different groups and different chats, and this guy started suggesting me on some topics that I can select and try to specialize on. So silent payments are a type of payment that can be made to a unique on-chain address. For every payment, even though the receiver provided the spender with a reusable off-chain address. So traditionally, a user who receives payment should generate a new Bitcoin address for every payment. This is because receiving multiple payments to the same address reveals the same user received those payments, okay? Even if the outputs are later spent in a separate transaction. This is known as address reuse. So silent payments are a type of payment that can be made to a unique on-chain address for every payment, even though the receiver provided the spender with a reusable off-chain address. Okay. Using a new address often requires a secure interaction between the sender and receiver so that the receiver can prevent fresh address every time. However, interaction is often feasible in many cases. With silent payments, the receiver can generate and publish a single payment address, eliminating the need of interaction. The sender then selects one or more of their chosen inputs and uses their secret keys together with public keys on the silent payment address to derive a shard secret, which is used to generate the destination. The intended recipient detects the payment by scanning the transaction in the blockchain and performing an ACD calculation with the summed input public keys of the transaction and the scan key from their address. The main downside is that it's more computationally expensive than simply scanning the UTXO set for a script pub key. Additionally, using silent payments in a collaborative setting such as CoinJoin is left for future work, and there remains an open question whether such collaboration can be made probably secure. Okay, so there's a BIP also for this. It's proposed. Josie Bake and Ruben Somsen. It sounds familiar to me. Okay. Okay, so I'm not really 100% secure. Using a new address for each Bitcoin transaction is crucial aspect of maintaining privacy. This is secure, send and receiver, blah blah. Our interaction is often infeasible in many cases and undesirable to solve. For this, various protocol has been proposed, which use a static payment address and notification sent via blockchain. These protocols eliminate the need for interaction, but at the expense of increased cost for one-time payments and a noticeable footprint in the blockchain, potentially revealing metadata about the sender and receiver. This proposal aims to address the limitation of these current approaches by presenting a solution that eliminates the need for interaction, eliminates the need for notification, and protects both sender and receiver privacy. These benefits come at the cost of requiring wallets to scan the blockchain in order to detect payments. This added requirement is generally feasible for full nodes but poses a challenge for light clients. While it is possible today to implement a privacy-preserving light client at the cost of increased bandwidth, light client support is considered an area of open research. Okay, so the design keeps collaborative transactions such as coin join and inputs with multisig and frost keys in mind, but it is recommended that the keys of all inputs and transactions belong to the same entity, as there is no formal proof that the protocol is secure in a collaborative setting. So this is really it's a proposed status. This is what I wanted to say. It's an immature proposal. It has to be discussed, explored, and it's not sure if this can be really implemented in a secure way. I'm curious about this. Okay, now I wanted also to check paynims. Jesus, man, come on. Did I spell it right? Paynims. BTC Optech. Se vabbè. What the fuck is this? What the fuck is a paynim? So the first which I checked was silent payments. Paynim. Maybe I took a wrong note. Okay, whatever. I will just leave it like this, so I have an idea about silent payments. Not sure about the mechanism, how it's really implemented. Let's see here if they're correlated to other. So specifying sending silent payments using PSBT. What the fuck is PSBT? Partially signed Bitcoin transactions. Wow, so this is a really old topic, the PSBT. Silent payments instead look like newer. So this looks like the innovation that this technique of silent payments proposed by Samsung has no additional overhead compared to regular transactions. Okay, so basically it's like hiding some amounts of Bitcoin in the blockchain, and the only one which can find them is the receiver. However, they have to scan all the blockchain for it, and if they don't know it, maybe they will not scan for it. So okay, nice. Therefore, we have an idea of all these topics, and all of them have already a BIP. Some of them have less mature BIP. Some of them are really attract a lot of attention, like the covenants and the ARC protocol. Also, it's something that is discussed a lot and kept in consideration. Therefore, yeah, I'm happy with this. I can continue my activities of studying these topics. Now that I have a big picture, I will just need to make some more. Then my first article, I think, will be on one of these topics, and sincerely, it may be the covenants, which look like the core of many discussions going around. They look like really relevant to understand things like the ARC protocol, which may be the second step of my delving into this technical stuff. And then there's also the BitVM thing, which really is interesting, even if it's new and still immature. It looks like they're still having some issues, if I'm not wrong, on determining if someone really executed the program, which is part of the contract. Therefore, yeah, I still need to think a little about it, but I think I will go with covenants, doing what I mentioned when I finished to review the covenants BAPs. And yeah, that's all. I'm already tired to talk so long, so I will close the video here. Thank you very much for being here. I appreciate it every time. See you in the next video.